In a couple of minutes. I think I see if everybody, we're just going to start in a couple of minutes anyway. Get started in a couple of minutes anyway, just get us. I don't know if there's, hopefully there's enough seats for everybody. Aye, whatever, it's up to you. No, I'm fine, it's nice breeze coming in anyway, yeah. Aye, no. Busy anyway. Right, we'll get started. Welcome everyone. It's great to see so many faces tonight. Lots of familiar faces and lots of new faces. It's good to see the meetup continuing to be so busy. Really excited about tonight. We've got a great lineup tonight, and I knew it was going to be busy. So we've been in getting all the kind of chairs out of lots of beer and a few more pizzas in. So great to see everyone. We've been running the meetups in here for probably close to 2 years now. I think it's the first time we've ever done a fire alarm. So there is no fire alarm scheduled tonight. If the fire alarm does go, you exit via reception, and if everybody meets up at Benson's Bed and on Bell Street, that's us sorted. So we'll get that done. So lots to we'll get this started. There's lots to go on with tonight, and I'd just like to introduce Joe Chow. We've had this booked in now for probably about 11 months, so I'm looking forward to this one. Joe's a data scientist at H2O. Sorry, he's been very busy this year. Joe's been travelling all over the world, talking about his company, talking about what they're doing. So welcome, Joe, to Scotland. And I'll introduce you now. Thanks very much.
Thank you. Hello, everyone. Thanks for coming, and thanks for having me, Michael. So this is my first time visit in Glasgow. So always want to find an excuse, the perfect excuse to visit Scotland. So this is one of the best. So all the slides will be available. So I already posted a link on the meetup page, so you can download the slides in PDF after this. So you don't have to take any picture of that. So before I start, okay, how many of you have heard of H2O before as a company and software? Okay, just a few friends. That's good because I'm here to talk about H2O. So I want to tell you about H2O. So this is the agenda for today. So first of all, I want to give you an overview of the company and people behind H2O. And I will give you another quick overview of the software itself. So it's an open source H2O machine learning platform. And hopefully I will have enough time to show you 2 demos. The first one will be H2O, running H2O on Hadoop. So that's on big data. The other one will be another feature in H2O was quite new. It's called automatic machine learning. So hopefully I will have enough time just to show 2 demos. And then maybe a few more minutes for question and answers. If you can't hear me, or if you have any questions at any time, just raise your hands and let me know. Is that okay? Yeah. So very quickly about myself. So you can see that the first 10 years of my career, I was a civil engineer. I was the boring traditional engineer. So at some point, I did a PhD with Exeter. So they want to combine machine learning with auto engineering. So that's how I get started with machine learning. And then I discovered H2O back in 2014 and start learning about H2O and then start using this for different kind of machine learning problems. And I fell in love with it, really. So I've been using it before I joined H2O. So I've been working at Virgin Media in UK. And then at the same time, I also work part-time for Domino Data Lab. So Domino Data Lab is not the Domino Pizza Data Lab. So it's another data science platform in Silicon Valley. So and then last year, about February last year, I joined H2O. So it's actually a long story about how I got into H2O, but I won't do it for today. Just want to quickly go through the journey. So back in 2014, I did a side project to create visualizations about the crimes in UK. So I created a map. It's like an owl shiny map that I can show it to anyone. So and then I submit a poster to the Use Owl conference in UCLA. They accepted, so that's why I went to UCLA for this conference and meeting all the people in the data science field. That was really exciting for me because I was a civil engineer. So I never know that I could attend some conference like this. So I went there, and then I saw this legendary guy called John Chambers. So anyone know John Chambers? Okay, so he's a legend. So he mentioned about H2O as one of the very promising projects that he found that we should spend time on it. So I gave it a try. I like it, and I use it for cargo and for other things. I wrote a few blog posts, and they like it. So that's why I end up with Domino and then H2O. And that's the short story. OK, enough about myself. So this is the company overview. So you see this, we are still a really young Silicon Valley company. So it's about 6 years old. So we were founded about in 2011. The headquarters is in Mountain View, California. We have about 75 people right now. Our products, the main one is the H2O open source machine learning platform that I will show you today. We also have other products called Sparkling Water, which is our integration with Spark. Stream is another thing that we can use it for deployment. And Driverless AI is our next generation of H2O product, which is not open source, unfortunately. So this is like an overview of the company. So we are very lucky to have professors from Stanford to be advisors because we implement some of the algorithms from scratch. So we want to have someone experienced like them to guide us through a journey. So we're lucky to have them. And this is like a simple graph to show the momentum of H2O. So back in 2014, when I first heard about H2O, there was no one knew about H2O, even in US or in other places. But a few years later, we see that there are more companies and more users using H2O. They're not necessarily our customer, but they're users of H2O. And then we kind of see that there's some momentum of H2O as a tool for machine learning in the industry. And we also care about the community expansion. That's why I'm here today, because I want to tell more people about open source H2O. So we have so many different meetup groups around the world. So I'm mostly in charge of the places in Europe. They also wanted to send me to Asia later on, but I try to refuse it for now. But we try to host about 15 meetups a month in different places. If you want to find out the next events available near your area, you can go to this website here. It's our website, H2O AI, and then community is the address. So here are some of the customers that we can tell you about it. So we can see H2O is a generic machine learning tools. So you can apply it in different sectors, different industry. So for example, for retail, we have Booking.com in Netherlands. In bank, you have lots of different big banks that we are working with them for a long time. And recently, we have this success here. So we've been working with PwC for nearly 2 years, but we couldn't say anything about that because they want us to keep it quiet. They don't want the other three of the Big Four to know anything about this. But recently, they have won the award, Audit on Innovation Award of the Year with the project that we work with them. So it's like an app that combines the domain knowledge with H2O as an AI engine to create an app that you can quickly narrow down some of the dodgy transactions in the system. So we save the time from human, like maybe 10,000 hours, human time, into a few seconds. And that's the significant saving for them going forward. And this is only like a small project to test the ability of AI. So there'll be more fun things to come with PwC and H2O. Here are some of the partners that we have. So we see that you can see that we work with NVIDIA, Microsoft, and IBM. So we work really closely with them to develop not only for this version of H2O, but going forward we have the open source version of H2O on GPU. And that's why we want to make sure that we have enough support from the hardware side of the people to make sure that we have the tools ready for the next generation of hardware as well. And we also have different partners on different things. So for example, MapD here, they're working on a database on GPU, which is super cool stuff. So to work together, we want to create like an open source initiative of machine learning on GPU with MapD and NVIDIA. Okay. So I just want to show you some of the faces of our team. So not all of them are here, but some of them they're quite shy with the photos. So I'm here in UK. So this is our team in Europe. So that you can see that not many people in Europe. So here UK, Mario's and a guy in UK with me. In Germany we have Matthias, and then in Czech Republic we have 2 guys. So that's us in Europe. So what exactly do I do at H2O? So on paper I'm a data scientist for them. So that's what they told me to do in the first few months. But then they found out that I'm the only guy in UK when I first joined. So okay, Joe, can you do some sales? And okay, yeah. And then can you go to speak at a conference? Yeah. And then can you organize a meetup? Yeah. So can you actually grow the community? So yeah. So when you work in a small meetup, small startup, you do kind of everything when you can. So that's mainly my roles at H2O right now. But because they asked me to travel a lot, so I also find a hobby, and I become one of the photographers. Like I'm an official photographer of H2O AI swag. So I have the stress ball with me, I have a water bottle with me when I go travel. So that's why I've been trying to doing a lot of photos, posting on Instagram and Twitter. So I'm kind of like a marketing guy for them. So, but I call myself the traveling data scientist for H2O. And one of the reasons I'm here, I want to give you some stickers. So there's some sticker on the table there. Please help yourself. And then this is like, when I look back this year, so what have I done this year? I've been traveling a lot. I know I've been traveling a lot, but I couldn't really picture how many cities I've been to. So I sat down and then wrote down all the cities I've been to in all the months. And it was crazy. So if that's the first thing that they told me that I had to do, I may have to think about the offer they gave me. So you can see that I've been traveling around different places mostly in Europe and sometimes in America, in the Bay Area. So today I'm in Glasgow, and 2 days later I'll be in Bay Area for the conference of H2O, and come back for one more meetup in London, and that's Christmas. So I can almost see Christmas now, so it's almost there. And if you happen to be in London in December, on the 12th of December, so we will have another meetup in London. So should be my final event of 2017. So we have a meetup there with I think it's full right now, but there'll be some people dropping out later on. So please, if you want to join our meetup in London, please go to our webpage. So this is the London AI and Deep Learning meetup. So that's one of my meetup in Europe. Okay, so that is enough for the H2O company. I want to move on to the main focus of today, is the H2O machine learning platform. So this is the high-level architecture, but you cannot digest all this information at once, right? So I will start with the left-hand side. So these are like the connectors of different data source to H2O. So because with machine learning platform, so the first thing you need to do is to connect to your data, right? So we support 5 different sources. So from Hadoop, from somewhere on the internet, from local drive, from the traditional SQL database, and we can connect H2O to those sources and get the data from there with different kind of 9 different formats. But most commonly is like CSV and Excel file and maybe some on Hive like that. So these are some of the formats that we support in the open source H2O. And then we move on to the Mythos. It's like the heart of H2O. It's the compute engine of H2O. So all these are written in Java. So I don't know Java myself. I'm not a Java engineer. But the co-founder of H2O and all the engineers at H2O, they're like world-class Java engineers. So they know how to optimize the usage of memory, how to make it scalable on different machines. So that's why they use Java. They provide an engine that you can just load your data, have a look at the features, have a look at the numbers, create a model like a supervised model or unsupervised model, save the model, use it for predictions, and you can also export the model for later users, for deployment. So that's like the heart of H2O. So I want to show you a few graphs to illustrate the process of H2O from a single machine to multiple machines. So first of all, this is what you would do when you first try H2O, maybe on your laptop or any single machines. So you deploy H2O as a Java, like a single Java jar on your machines. All you need to have on the machine is the Java 1.7 or above. Then you will utilize the memories, the CPU, and hard drive for H2O for machine learning. So it's just like any other tools in machine learning, right? But the good thing about H2O is that you can scale up quite easily. So all you need to know is the IP address of those machines. The perfect way to do is all in a good network. And then you have all the IP address nicely here for each one. You deploy H2O as a Java on all the machines. Then you can connect them together as a big cluster. So when you do that, H2O can utilize all the memory across the machines and all the CPU resources that you allocated for H2O, as well as the hard drive. So what happens is that H2O in the back end will distribute the workload across all the machines because we build this H2O platform to be scalable. So we are not using just one machine. We design H2O for multiple machines. So each time we build a model, so this is an example for GBM or gradient boosting machines. So all the algorithms that you can find in H2O, they are like this. They can scale to more machines when you have more machines available to H2O. And these are some of the algorithms that we have in H2O. So it covers most of the common things for both supervised learning and unsupervised learning. So for example, on the left-hand side, we have supervised learning, meaning you have the answers. You just want to look at the answer in the past to predict the future. So what we have is the common like GLM, the generalized linear model, random forest, GBM, the gradient boosting machines, and deep learning, so deep neural network for supervised learning. And for unsupervised learning, meaning you just want to forward data into the computer and get some answer from that. Maybe you want to do clustering. So we have k-means for that. If you want to reduce dimensions sometimes, you can use principal component analysis, PCA. And we have another cool thing here called the generalized low-rank model. So it's one of the new algorithms from Stanford. And then you can also use deep learning for autoencoder for the unsupervised learning. So there, will not cover like all of ecosystem in Python and R, but it's more useful for most of the problems that you will find in a tabular data set, like for business analytics, for things. Okay. So back to the picture. So this is how people or users or customer will use H2O in a more commercial environment. So sometimes they want to have a firewall or maybe in the cloud just to surround it, and they can deploy H2O on top of their Hadoop system. So because when you have Hadoop, you already have the infrastructure. So you have the machines already in the company that they have the data on different hard drive. If you want to use H2O, you don't have to purchase, you don't have to buy another set of machines to do machine learning. You can use the same machines here, deploy H2O as a jar file on top of all the machines here, and H2O can utilize all the data from the Hadoop system or this system here to do the machine learning for you. So you don't have to pay more money on the hardware to use H2O on your existing system. And that's very common use case for our users. So just put it on either on the cloud or behind your own firewall, so nothing else will go outside this firewall. So I'll talk about HTML is written mainly in Java, but I want to show you that HTML we have different interface for different users. Now for myself, I'm not a Java guy, so I don't know how to use HTML with Java. So if you ask me that questions, I'm dead, so I cannot answer that. But I use R and Python with HTML. And that's how I first learned about HTML. So I use this interface to interact with HTML. So the main commutation is still done in Java, but we are using HTML with R and Python as the interface to communicate the commands to HTML. The thing that I want to show you today is called HTML flow. It's even easier for people to use HTML because it's a web interface. So you can just open a web browser, activate HTML on the same machines, point to the IP address and the port, and you will have the interface to work with HTML. Something like this. So all you can see is that this is like the web browser, any modern web browser will do. Point to that address and port, and you will see an interface here. I want the user to like import data, build a model, make some predictions, export the model, all using just click and select, which I will show in a live demo. Yet, if you prefer to do HTML in a more programmatic way, so you want to use a scripting language like our Python to use it, that's also possible to use it. So you may not see it in details, but the code inside here, you can see no trace of Java. They're all like just the native R and Python code, so you can use it without learning any Java. Okay. And finally, so once you have the model done, some people may not care about this bit, but this is quite important for our users, is to deploy the model like a standalone object, get the model out, put it away to deploy it on someone else's machines, and that we can do it with HTML. We export it as a Java object, and then you can leave it to other people to use it on their preferred environment. So this is like some example of an environment that you can use it for scoring. Okay. So I don't have time to go through all the details of how to use HTML with R and Python, but I do have the materials online. So after that, when you download the PDF, you have the links to my previous training materials for either using HTML with Python or with R. So both of them, they're just good enough to show you the basic step, from basic to more advanced step in using HTML for machine learning. Okay. I do have the video on YouTube as well. So if you want to see me again, so this is your chance, right? And so more importantly, I want to show you this page. So this is the document site, so DLCS. So if you can see it, DLCS.html.ai. So we try to centralize all the information about HTML, so all the reference, or the tutorial, or the template, or the code examples, all on one single page. So it's a document, so dlcs.html.ai. So this is the page, this is the slide that I want you to remember today. And when you go home, if you have some problems about HTML, go to this one first. Go through all these different products, go for the answer, and use a search box to search for the answer. And that's a good site for that. Okay, so I'm about to go into the demo, the first demo. So is there any question about HTML before I move on to the demo? All happy? Okay. Yes, please.
What's going to happen with the open source edition when you're going to the new one?
Oh, this will stay. This HTML3 this is the classic open source HTML will stay forever. That's what I've been told, forever, right? Forever. But yeah, because it's like a mature system. I'll talk about how we make money with this open source. So we provide support for our customer. So we don't sell this software. This is open source software. But we still sell the support that maybe we can go there, give them training. We can go there and help them to deal with their own business problem. So maybe like a data science consultant to them. And then that's how we make money. And all the things that we learn, all the challenge that we have with the customer, all the things that we improve, all the bug fixes, all the things that we did for the customer, all go back to the open source version. So that's only one version of open source HTML3. But this is like the mature product from all the things that we did with the customer, all going back to this single version of actual open source. So the users will benefit from all the things that we did for the customer without doing it. And that's our business model, which I think is quite cool. Okay, so So I want to just go through a few slides about the next demo. So I want to show you the power of using H2O on a big data set. So this is one of the data I got from Kaggle. So how many of you have heard of Kaggle before? Oh, great, great. So you know that is a data mining computation site. So this is like quite a few years ago, I guess. They have communications about the Higgs particle. So they have some sensor data like this. So they have some sensor data as a predictors, and then you have the outcome here, which is this particle a Higgs particle or not? So yes or no. It's a binary classifications. So what people were asked to do is to learn the pattern here. So we're using machine learning to learn the pattern, whether they can use the sensor data from the X there to predict Y in here. And that's what we try to do in this demo here. So the figures I want you to remember is that this is not a small data set, so it's about 11 million rows, all samples. And then the feature-wise, it's not too big, so it's only about 28 features, I guess. Yeah, 28 features. It's not really wide, it's a small feature set, but a lot of different samples. So I want to illustrate two things. First of all, when you import data set into H2, it's really good at compressing the data set. So the raw data size of that CSV file is about 7.5 gigabytes in size. But when you actually load it into H2O, it compresses into about 2 gigabytes in memory. So meaning that if you have like just like a laptop for this combination, you can still do that. So if you're just using open source Python or R, when you load in the dataset, you don't have much memory left to do anything else. So, but with H2O, you only use about 2 gigabytes for holding data in the memory, and then you can have the rest to do machine learning. And that's one of the first thing I noticed with H2O when I first tried, because I have a really crap computer when I first used H2O. But it was much better than other software tools at the time to handle big data set. Big was like a relative answer in that time, but it helped me to use my laptop, my limited resource, to do something cool. This is like just a quick, you may not see the details. It's just like I connect 10 machines together. So each machine, they have 32 virtual cores, or like the threads that you can use for computing. And altogether, H2O combined together, we're using all of the CPU resource available for this cluster. So we are about using 320 cores together for the calculations. And we're also sharing the memory as well. So each of them are located about 30 or 29.5 gigabyte of memory for each machine. So 10 together, we have about linear 300 gigabyte of memory. So this is one big beefy machine for machine learning. And one more graph I want to show you is the water meter, we call it. So it's just like a CPU monitor with a web interface. So when I try to do machine learning, you will see that the green bar going on, which is green is meaning using the CPU for doing something, right? So you will see something like this, meaning that we're using all the CPU on all the machines to do something for the model. And that's what I want to show you in this demo. Okay, so this is the moment of truth, if it works. Okay. Okay. So first of all, I want to show you this. This is the interface. I'm going to make it bigger. Give me a second. Okay. So this is what you will see when you start H2O interface on the web browser. So you see lots of options on the top. And then you see this section here. This is like a help section. This is quite important because I want to show you, because here you can see that there's some example flows in here. We call it flows. It's just like notebooks in other tools. If you click on that, you'll see that there are more examples in here. So after this meetup, if you are interested in learning how to use H2O with R dataset, please go to this one and just try to go through some of the workflows here, and then you get a sense of how different datasets, different algorithm is working with H2O as like an overall view of different algorithms. Okay, now let's close that, and I'll make it small again. So don't worry if you can't see the details about it, because the main thing I want to show you today is this bit here, is the usage of CPU. So this is like a cluster I set up like a few minutes ago with 10 machines together. So each of them, they have 32 cores, so same as the size I showed you earlier. So now it's not doing anything. I'm not too sure why they're doing something there, but let me just do a refresh. Okay, that's better. Okay, so they're not really doing anything right now. So the first thing I want to do is to import a dataset. So I want to say that this is like a URL that is internal to H2O. So I'm connecting to H2O VPN right now. So this is like internal Hadoop system. So no one else can use it. So I will import this. So again, you don't have to memorize this step. I just want to do it quickly to show you the CPU usage. Oh. Let's try again. I'm just pointing to that big CSV on the Hadoop system right now, and then again, ready to parse. So when I click plus, it's not going to do it the first time. So it will ask you some questions first. So this is the page that H2O asks the user some questions. So are you happy with these options here? So for example, they're all numeric, but for my experience, I know that the first one is not numeric because it's either 1 or 0. So I want to change it into elem. Elem is the categorical value in Java. So that's why I changed to that. So otherwise, we will do regression instead of classification in H2O. So that's the only change I want to do. So when I'm happy with that, so when I click that, it will use all the CPU resource to get data into the system. So it should work like that. So when you look at the graph, come on. Okay, so it works. So that's done. So in about 5 seconds, so we load about 7.5 gigabyte data into the memory of H2O. And the compression is about, let me just look at this. So now you can see this is some information about the data set. So it's maybe too small, but let me show you. It's 11 million rows, 29 feature-wise, but one is the outcome. And the memory usage is 2 gigabytes. So from 7.5 gigabytes to 2 gigabytes. So you have to trust me that originally it's about 7.5 gigabytes, right? But that is a compression that you can use in H2O and to save you more resources for other things. And once you have the data in H2O, you can do some quick exploration. So for example, you can look at any of the features. Maybe the first one here, I click on C2. So all it does is just a simple graph to show the distribution. So you can see that for C2, I don't know what it is, but you can see the distribution like that. And this is quite useful for people to just drop the data into H2O and do some quick exploration using the web interface. OK. So now I have the data in H2O. I want to do a split. So I want to do a split framed. So the reason why is that I don't want to use the whole data set to train the model. I want to split it to maybe 75% for training, and then the last 25% for validation. Because you don't know how good your model is. When you have the model, if you can memorize everything about the model, it may not generalize to the future data. So I want to split it into 75 to 25 for that, and I call it training and validation. So in H2O, you can also specify a random tip in there, and then just make sure that next time you can do the same thing, with the same result. So I select that. Okay, create. Okay, so what happened now is that I have the same data set, but split into 2 different sets, so training and validations. I'm going to use the training data set to train a model, and at the same time, I want to use the validation to validate the result along the time. So this is how I do it. So you go to model, you go to GPM, so it's gradient boosting machine here. And this is demo, so I want to give it a name quickly. GPM Glasgow demo. So now I choose the training thing, which is 75% of the data. I want to choose the validation thing, it's 25% of data. Then I tell H2O C1 is the outcome, it's the either 1 or 0 outcome that I want to predict. And that's it. So mainly, that's it. So there are, of course, a lot more different settings for GPM. That if you know that for different machine learning algorithms, there are a lot of different settings to tune. But I'm not going to tune it. I'm going to leave it like a default value like this. The only thing I want to add would be here. I want to score the tree every 10 trees. So I can see the results going down, the performance going down, or the errors going down across time. So that's it. So I'm ready to build a model. So when I click that, you should be able to see the CPU usage going up again with all machines. Okay, please do it, go. Okay. Okay, so now you can see that, so with a few clicks, you can utilize all 10 machines, each of them with 30 cores, so 320 cores running parallel for this problem. This is not a really complex model, so we're not utilizing all the CPU because it's quick to calculate and get the tree score. But if you have a bigger problem and more complex, maybe more features, so each tree will take a longer time to train, then you will see the usage like full for a long time, rather than just half like that. But this is just to give you an idea that if you have like a machine like this, like a cluster like this, you can train a model like for this GBM model, train it for 11 million records in about 41 seconds, and that you have the model. Okay. So after that, you can look at it quickly. So I just want to show you quickly about the model. So because I have the validation as well, so you may not see that there are actually two lines in there. So one is orange, the other one is blue. The blue is the performance of the training data set, and the orange one is the one for validation. So in this case, it actually is quite nice because you can see that the validation model also improves when the training model is improved. That means that this model could generalize quite well for the training for the validation data set. We can also look at other numbers. So this is the AUC, the area under curve for training. And the next graph is the area under curve for validation. So again, they look quite close together. So it's 0.79 for both. So it's quite close. So in this case, you say the model is quite stable, for this problem. But sometimes you may see that you may have a good model for training data set, but you have a really worse performance or much worse performance on the validations. But this is not the case. This is a stable model. The other thing I want to show you is this graph here is about the variable importance. So because you can see that the variable doesn't mean anything to me because I don't know much about the variables. But this graph here is telling me that maybe C27 here is the main driver of this model in this case. So I can take this information and take it back to maybe the physicists to talk about, do you think that these features are the most important features in your data set? And if not, why? So this is like using a data-driven approach to compare with the domain expert approach with one graph. So do you agree with this graph that we showed here? The main drivers are C27 and the other, etc. That's quite useful to start some discussion with the domain expert. Okay, so that's what I want to show you in the first demo. So let me just move on to the slide again. Okay, so just want to show you how to use H2O on scale. So how to scale up H2O. So actually, you can just scale up with more machines. And if you have a bigger data set, you can do it in shorter time. And that's how we do H2O. Okay, so the next one is another feature that is quite useful for not only for data scientists, for anyone that will want to use H2O to automate some of the tasks that is quite complex and time-consuming. So we call it AutoML. It's the automatic machine learning features in H2O. So what happens is that we have this feature in, but it's not like doing everything for you in one go. You still have to care about the data, so you have to do all your data integrations. You have to do the quality check. You have to transform the data set if you need to, and you have to make sure that you have a final clean table that is ready for machine learning. So that we didn't automate that bit for you. But once you have the table here, so once you have a nice table here ready for machine learning, then we can use H2O automatic machine learning to do this bit for you. What it's doing here is trying all different algorithms in H2O. So because we don't know which algorithm is the best for this data, we don't know what settings are the best for that algorithm. So we're using this process here to test everything for you at a given time. And by the end of that, you have the model that you can use it for productions. This is like one of the results. So I did an experiment with AutoML, and it will give me back like a feedback, like a table of different performance. So you will see that different algorithm that we tried at H2O. So GBM is the gradient boosting machines, DLF is the distributed random forest, etc. So we try different things, and then we try to combine it together using the stacking. So it's not only about the model averaging, it's about stacking model together. And this is like a graph showing that which combination is the best. So we think in this case, the stack ensemble with all the models together will give us the highest AUC, which is the best model in this case, the area under curve in this case. And then on the other side, you can also like minimize the log loss. So in this case, lower is better. So again, this one is also lowest in terms of log loss. So this is like giving you more information about which model is the best for that data set without the user doing all this thing manually. So this is quite cool for people who just start with machine learning. So I want to use a simple demo to illustrate the purpose. So this is a simple data set from a bank in Taiwan a long time ago. So it's about the default payment of credit card. So what we have is some information about the customer. So we have the gender, the education level, the marriage, the age, and some history of the payment in the past. And then at the end, we have the outcome. So whether did the customer pay back the credit loan on time or not. So are they a bad customer or not good customer? So this is the data set. So what we try to do is do the same thing again. So we want to learn from this data. So learn from the credit card information, the customer information, the payment history of the customer, and then we have the outcome of different customers in the past. So whether they default the payment, yes or no. So again, it's a binary classifications. So we want to use H2O AutoML to learn the pattern here, and then we can predict the outcome in the future. Okay, so let me move back to the web browser. Okay, so this time I'm going to use H2O on my laptop. So this is running on my laptop. So let me just make it bigger this time. Okay. So first, I'll just upload the data. Okay. So again, so when you point it to, I'm pointing it to a CSV file on my hard drive, and that will give you like a quick summary of different data sets. So you can see this like customer information, the gender, the education level, whether they are married or not, the age, and then some history of the payment in the past. So I know that I need to change one thing again. So this one, the default, which is the outcome, which is whether they make a payment, yes or no, is a binary classification. So I want to change it again to ELAM, to the categorical label. So that's all I need to do. So I go to parse it. So it's now in H2O. I can then again, I can do some quick explorations. I can maybe look at the age. So you can see there's like a quick distribution. So again, I just want to show you some basic function of H2O using the web. So now I want to build a model. But this time, if I look at the list of all the algorithms that's available in H2O, I don't know which one is the best for this data. So what I want to do this time is to ask H2O to just try everything for me at a given time. So I do the last option here is one AutoML. So this time I want to call an AutoML demo. So you select the data frame. This is the credit card that I just import into H2O. I want to select the response column, which is the default is either 0 or 1, yes or no. And you don't have to care about that. That's for cross validations. And what we ask the user to do now is maybe you can specify a random seed here. Is that we ask the user two questions. One, how many models do you want to build? Or two, how much time have you got in terms of seconds? So this time I want to say maybe 60 seconds. So what H2O will do is to try as many as possible within that time frame. And then by the end of that, we'll just do a stack ensemble to stack together all the models and see which one is the best for this data set. So of course, if you have more time, then H2O is allowed to test more, then you may likely to have a much better model. But for this today, I just want to show you a quick demo that how this can be done in real time. So you can also look at it in real time. So you can say, so H2O is now trying different models. See that the first one here is the DLF is the random forest. This is the first model that it tried it. And then you have a score for AUC again, for AUC, area under curve, and log loss. And then at some point, we'll finish the next model. Then you'll see, OK, another model is better. So it's an extreme random forest. And then now we have another GLM, the general linear model. So it's keep trying different algorithm in the back end. But user only need to specify the time, the data frame, the outcome, etc. And that H2O will just do all the work, all the complex work in the back end. So all we ask the user is just to provide a time or the maximum number of models, and H2O will just do this for you, quickly. And this is quite useful because imagine if you just got into data science, you may not know which algorithm is the best for this data set. You may not want to just spend your time just tuning everything, all the algorithm, other things that available in the algorithm to just fit this data. Alternatively, you can just say, I have this time, I have 1 hour, 2 hours, etc. And then you can just set off H2O on AutoML, and then you can go and watch Netflix. And then you come back after 1 hour, and you have the model ready for you. So what's done here is that, so after like 60 seconds, you spend another 10 seconds or so to create a stack ensemble. And then you can see that, I'll make it bigger. So then you can see this is like the top model here, which is a stack ensemble of all the models together with model stacking, and it will give us the best in AUC and the lowest in not loss, which means that this is now the model that we might want to use for this data. And then you can just use this model to make predictions. So if you click on that model, and then you have the option to use it for predictions, to export the model as a POJO, to just put it into production in the next step of the pipeline. So that is what I want to show you today of the function in H2O that you can automate this bit to save the time. Okay, that's the second demo. So just one more thing about the events that we have very soon. So it's December the 4th and the 5th. So very soon. So after this meetup, tomorrow I'll go back to London and I'll travel to San Jose for this event. So if you happen to needing excuses to travel to California, just let me know and I can give you a free ticket. Otherwise, we will have the live streaming event soon. We have the link. I'll post it on the same meetup page, and then you can just look at the live stream videos for that event. But it's a cool event for different H2O users and customers come together and they discuss the use case. So you can hear from, not from us, from our customer, how they use H2O to transform their business, which is really, really cool. So I want to say thank you again, Michael. Thank you for having me again. Thank you for this group. Thank you for coming today. If you want to look at not only for this meetup and for all the previous meetups of H2O, you can go to this website here. It's on GitHub, so you can download all the PDF, all the slides from previous events. The document site is the one that I want you to remember, just to go back for all the reference. I'm the only Joe in H2O, so I'm still the Joe at h2o.ai. It's quite easy to remember. I usually have a quite evil Twitter handle, but don't ask me why. That's my GitHub. If you want to search for answer about H2O, please use the tag H2O instead of H20, because many people get it wrong. So if you use H2O on Stack Overflow, I think you should get the right answer quickly. So that's me. Thank you for your time. Yeah. Yeah.
Anyone get any questions?
Yes, please.
See, in your AutoML demo, when it's running different models,
yes,
is it trying different types of models? Sorry, is it trying the same type of model multiple times with different parameters, or is it just a default set of parameters?
Yeah. So we're trying on the same data set, different algorithms, and each algorithm, different settings for different algorithms. So it's a lot of things going on in the background. But if you have more time, then for each algorithm, there are more chances to try different settings in that. So it's like a random research for each algorithm, as you know. Yes, please.
You showed quite an interesting feature importance.
Yes. Yes.
So, what sort of the additional information H2O gives you, rather in addition to giving you, okay, this is the model.
Yeah.
What we think this feature is important. Is there any some additional sort of information to just sort of give a justification of why that feature was important, like all the feature selection algorithms that goes behind that?
Yeah. So that is so two things. So in open source H2O, we have that variable importance graph. So we're showing just a number to show which one is more important, but we didn't explain why this is more important, right? Yeah. So I shouldn't talk about commercial product, but because you asked, so in a Java's AI, so we have put in more work to try to explain from the input to the outcome. So how does this input, maybe input A, B, C, go through this complex model? So after this complex process, why does it come to this outcome? And why does input A have a higher importance than B? That is what we've been trying to do in the Java's AI, which is the commercial product, like a next generation of H2O. But that is not available in H2O open source, but there's a package called Lime, so Lime, Lime, so it's another open source project to explain model from black box to some recent code. So now recently we have the guy from Denmark, we have the Lime package in our who actually implement more information, features with H2O. So you can use H2O to build a model and use that package to explain what H2O is doing from input to output. That is exactly the topic for the meetup in London next month. Yes. So if you, yes, this is.
Thank you.
Okay.
How are you ranking the features? What sort of calculation are you doing?
You mean ranking the features? Okay.
Like what he said there, you showed that this
Yeah.
is the most important feature. How are you scoring?
Yeah. So it's different for different algorithms. For example, random forest is quite easy because for each random forest, for each tree, you omit some of the features. So if every time when you omit the features, you have the score for the out of sample performance. So we use that every time we have a different random set, and we use that the difference in performance to calculate the importance of each feature. So for example, if this feature every time you take it out, the performance will go down, then that means that you have a higher importance. So that is for random forest and gradient boosting machines, similar. But we do have something different, slightly different for deep learning and other algorithms. Okay? Yes, please.
So based on the time, is it possible that if you don't give it enough time, you're not able to just give it over because the possible samples of each other
Yeah, true.
so you will not actually get the right result?
Yeah, so for example, if I just give it 10 seconds, it may not even finish the first random forest. So it will just show, okay, we don't have any model in this combination, it just failed. It will just feedback to user, hey, you may need more time to finish it. But in practice, in practice, you won't just say 10 seconds to give me a model. You say maybe 1 minute or more. So usually that would be enough to give you some quick feeling of the data, the performance, or which algorithm is better. Because what we want to do here is not only about automating the whole thing. It's about giving more information to the user. So for example, you use AutoML to do a quick check and say, okay, the top ones are mostly GBM or gradient boosting machines. Then you may, like as a user, you will spend more time to tune GBM for that data set instead of focusing on the algorithm. So that's other way to do it. So for basic users, so for first beginners, and then for advanced users, the different way to use AutoML. Yeah.
The compression, what kind of compression are you doing here?
I'm a software engineer, so I don't know. But they did something cool, something really, really cool in Java. So when we import it, so it's H2O when you start, it's a JVM, the Java virtual machines. I'm not a Java guy, so all I need is there's some magic. So from data going to Java, it's compressed.
Yeah,
Yes,
I've got one question.
Yeah.
Let's, for example, we get a whole set of data on a Monday. Would there be a way to automate all of that data going in through the H2O to then produce an outcome for Tuesday, so that each day we're learning automatically, so that if we're setting up automated scripts to pass some data to your engine?
Yeah, that is like a repeated, like a cycle. So every time you have data from today, you want to predict for tomorrow. That's what's actually happening with some of the company, like Booking.com or other things, because they want to use data, like maybe not today and tomorrow, but last week they have this data set. They create a model, they export the model as a Java code, so they call it a module. So either the plain old Java object or model optimized Java object. So we have two options to export the model. So they save this model for this week. Okay, so after this week, then they have new data set. They will drop the model from next week, from last week, and use the whole new data set to retrain the model. So it's not like updating the old model. It's like retrain the whole data set, export the model, and then do it again. That's how to do it. Yes.
Yeah, for your automatic machine learning feature, do you split the dataset further for model selection?
Yeah. So there's so if the user if they didn't specify the split, we'll do it for you. So it's I-75 first to keep 75 for training, and 25 for validations. And within that 75%, it's like fivefold. So within that training data is fivefold. And then there's like a test, like hold out for the last step to validate. So it's 75% for fivefold in there, and then 25 for validations. But the users can do their own specification, so they can supply like another extra column, like they can have row column 1, 2, 3, 4, 5 at different folds to specify how they want to do the cross validations in AutoML. So there are different ways to do it.
So you can tune this?
Yes, you can tune it if you want to.
Thanks very much, Joe.
Thank you, Michael. Yeah.
Thanks very much, Joe. That's great.
Right. Thank you.
Joe will be around for more questions during the networking session as well. Thanks very much.
Right.
Next up, Sylvain is the CEO of Francis. So, welcome to Sylvain. He's a guest over from Silicon Valley, and it's just by chance he's actually visiting Scotland this week with some of his colleagues who are up the back. So please say hello to them as well. They're based in Silicon Valley, and they're having a week in Scotland to have a look around to potentially set up their business here in Scotland, to start looking at building teams and hiring people. So it's great that you're here this week for the meetup. So we thought we'd invite him along to speak at the event, to kind of show him what it's Scotland's like, to meet some of the people within the industry. So warm welcome, and look forward to listening to you.
Thank you very much.
Cheers. Thank you.
So, as you just heard, I'm here with a team from Silicon Valley to set up shop here in Scotland. We were invited by the government of Scotland to evaluate. They also paid for the trip, by the way, which is cool. But of course, we're not here to do sightseeing. We want to evaluate business environment, the job market, and so on, and set up shop here. As some of you might know, the government of Scotland offers incentives for companies to come here and create jobs for you and for younger professionals. And as part of this, we went to Edinburgh. We visiting here in Glasgow and in Aberdeen. And so far, it looks very promising. Let me tell you a little bit about myself to create some context. I've been in Silicon Valley for the last 30 years, studied at University of San Francisco and Stanford. Been in a number of large companies, to the likes of Oracle, Sony, the typical companies in Silicon Valley, HP, Cisco, and so on. And banks, by the way, telcos, and so on. After being for about 10 years or so at Oracle, and actually let me talk a little bit about that because it's practically relevant. And by the way, I don't have slides, by the way, so probably we had enough for this tonight, but by the way, I do have plenty of slides, but maybe we just talk. What I'd like to do is maybe to engage you a little bit, see what questions you have as well about Silicon Valley and about what we're doing, but I want to set up a little bit of context before that. And so, as I was saying, I started actually in '96 at Oracle, at the time when Oracle was just finishing Oracle 8, which is probably the product that made Oracle what it is today. And the problems that we're tackling at the time is just organizing data and making databases viable for large use, but at the time, large was not as big as the big data today. It was pretty much relational databases. The focus was actually on OLTP, on transactions, databases that you could write to and read at the same time. With the introduction of larger database in application, then the need arose for OLAP. So basically run analytics over databases, and then pretty much everybody was creating data warehouses, and maybe a lot of you have actually done that, or are still doing that, because companies still do that. They get all the data in the enterprise and put them in a database. However, over the last 5, maybe 10 years, the paradigm has shifted quite a bit. And I think a lot of it was led by Silicon Valley enterprises, but it's not limited to Silicon Valley. It's actually probably around the world, and definitely anywhere in the US, to make a shift to where every piece of data is captured. Now with the advent of Hadoop and Spark and everything else, Kafka and so on, We have the computing power, at least we're starting to have it, and it's still improving, to capture every single piece of information. And machines have started now to emulate people in many ways, AI as well, by the way, but in terms of data, to act like we're acting. We store every memory, whether it's we remember it or it's deep in our brains, and we use our experience from life. We use what we learn in school, what we read in books, and so on. Many times what we can imagine, and that's something that computers are not doing, or at least yet, and hopefully not doing it anytime soon. But we use all this data in our decisions in every day, which now we can start doing with computers as well. So I'll give you a few examples just to illustrate, and that's what I like to do tonight, to give you a little bit of a glimpse of what's going on over the larger picture. We use tools, by the way, we use Watson and H2O and Einstein and Google and so on, the AI environments and R and SPSS and SAP and so on. But sometimes we get caught in the details. And we started the company actually noticing that communication in the companies, in society, is actually getting industrialized, similar to, let's say, manufacturing about 100 years ago. With the introduction of the assembly line, manufacturing was changed as well as society. At that time, people living during this change were not looking at it that way. Later on, 30 years, 20, 30 years, definitely 100 years later, we can look and see what the impact of that was. Quite a few researchers believe that actually we're going through a similar evolution in terms of communication. Machines now control communication. The majority of Fortune 500 companies actually have very complex marketing platforms that control the messaging. Of course, humans actually have a significant input, but communication is starting to be controlled by machines. And then we're in the middle of that. And by the way, data is actually a very critical piece in that. And the way it works right now is that every single piece of data is captured and used to control the messaging, to control decisions. Pretty much every message is considered to be an offer that's or a presentation that it can be personalized, and it's controlled by a number of attributes of behavior, external factors as well. To illustrate this a little, we have about a dozen Fortune 500 companies that we work with closely, and we've collaborated with others. Every single one, what they do is they store data about their devices, about their practices, about their customers. One of these companies, and by the way, you can look our customers up on the web. I don't want to go into too many details because some of it can be a little bit confidential. But one of them, for example, has 3,000 attributes about every single person, which is a huge amount of data. And then we're talking about millions of people as well. Now, in addition to that, just to illustrate, and this one I can actually mention because it's more or less public knowledge. Cisco, as you probably know, Cisco sells communication equipment, networking, and so on. What we've done at Cisco, for example, we took every single transaction from, for example, every single phone, switch, WebEx, and every other communication device, and put it in a big data environment. The amount of investment in such projects is literally in the billions, which is significant. But in the end, with the technology that we have today at our disposal, we can capture all this data and analyze it. And it's actually several layers that we use in the analysis. And in the end, we can actually predict, we can identify patterns, just like, for example, HTO, the presentation you saw today does, in a way that humans cannot do. And I'll give an example with that. How many of you, by the way, are programmers? How many of you code? So quite a few, more than half, I would say. So let's take a simple problem that now AI these days is using, and you probably saw quite a bit on the internet, differentiating between pictures of cats and dogs. It doesn't have an application in business, but still that's one of the things that you've seen with Watson, for example, or with other things. How would you go as a programmer, a 3GL programmer, so in Java, for example, or any other language, how would you tackle this problem? How would you, if you wanted to write code that differentiates or somehow can tell apart a picture of a dog from a picture of a cat? Let me ask you this, by the way. How many saw this thing, this application on the internet of cats and dogs? Well, very few of you. So let me then backtrack a little. One of the things that if you look into AI that's demonstrated quite often is that you actually show AI 100 pictures of dogs and 100 of cats, and the more you show it, the better it gets at differentiating cats and dogs. And I can tell you actually a little bit about how that works if you like. But as a programmer, since quite a few of you are programmers, how would you tackle that? Would you even know where to start? Anybody? How would you do it? Say again? CNN. Okay, but see, that's the AI type kind of, doing matrices and so on. How would you do it with a 3GL, with, let's say, an algorithm? If you were to write an algorithm, how would you do it? Yeah, it's almost impossible. So it's a paradigm shift. So the way AI pretty much works is that actually it creates matrices and several layers of matrices of data, where then it identifies patterns, okay? And then without understanding them, and we as humans don't understand them as well, we don't assume that the machine really understands how that works, but it identifies the patterns, and the more pictures of dogs and cats you're giving to it, the better it gets at when you're showing them a new picture, telling them that's a dog or that's a cat. Now we as humans, we do that pretty easily. If I show you a picture of a cat or a dog, pretty much everybody here will say that's or for the most pictures. There are some that you can't tell. But by the way, most of them, if you see a picture, you can tell. But if you want to write this in a program, you can't, okay? Now, with AI, you can solve these kind of problems. Now imagine that we're not talking about pictures of cats and dogs, we're talking about data sets, like we saw here, which are abstract. A data set doesn't mean much, you look at it, doesn't mean anything. Okay, if you just look at it. Now, if you start to analyze it, it may mean quite a bit. But what computers do, they look at these different data sets, they identify patterns, and then you can actually tell what's the next action, what does that data mean. You can actually predict, for example, if you see patterns of behavior, whatever they are, you can tell that this person might actually buy that product, or they might benefit, they are interested in this type of content, and so on. And a lot of these things are not done with necessarily the way we do, let's say, with logic. Because algorithms, the majority of the programming today, actually follows a logic. If you think of the way AI works, it's not really the same way, the same logic that we use in programming, and if then else. Okay? It's actually throwing a lot of trial at it and saying, well, this is that, and this pattern is valid, and this one is not, or this means A, this means B. And in the end, learning what is A and what is B, which the way we learn it is conventional. Let me throw one other aspect there that's again, just to paint a picture. We might not see things the same way. If, for example, let's take a color. Now let's take this tree there, red. Okay? We don't know that we see that color the same way, all of us. Some of them may see that color the way, so let's say you might see that color the way she might see the green color. We don't know, and we will never know why, because we can't express it. But what we know is that whatever we see there, we call red. If you and I see it the same way, we have no idea to tell. Because you don't know how I see it, and I don't know how you see it. But we both, whatever we see, that thing, we call it red. Okay? Now, in programming, it's the same thing. Computers identify something. They don't necessarily understand it. We don't know what it is. Okay? But they call it something, by convention, pretty much. And that's how AI pretty much works. And by the way, that's both an advantage and a disadvantage, because it doesn't mean that it gets intelligence or knowledge, but it can be very quick or very good at identifying something that otherwise you would have a hard time to code and program. Okay? Anyway, going back to data for a second. I'm going to give you one example, and then I want to see if you maybe have any questions about what's going on in Silicon Valley and what by the way, mainly about data because it's a topic here. But if there's anything else that I can answer for you, I'm happy to do it. So what I was saying at Cisco, for example, the project that we're doing is getting all the data from every phone to, for example, what kind of medium is used. For example, whether it's using video, whether it's using audio, whether it's using the data, for how long, in what way, what users are using it. So it's pretty much the different dimensions. What users are using predominantly what. Putting all that data, and we're talking literally about, let's say for a company, possibly 10 million phones, or I'm sorry, 10,000 phones, or 50,000 phones, and so on. And putting all that data, one in the hand of customers so they can actually manage their operation, but then capturing all at the level of the company so that they understand how society uses that. It's also frankly for sales and marketing as well, but it's also used to understand product development, what makes sense to do, and so on. Things that, let's say 5 or 10 years ago, we were not able to do. Okay, because if you calculate the number of transactions with all the records, a regular database cannot possibly hold or process that kind of data. If you run it over, let's say, an Oracle database or MySQL or whatever, it will take months, no matter how you do it, just to parse the data. And by the way, when we were working on Oracle 8, for example, it was a completely different paradigm. We were dealing with binary trees and linked lists and so on. Whereas now it's a totally different paradigm. What I was describing before in terms of establishing patterns and then converting, let's say, observations into patterns and then into data and then establishing the patterns of the data is a completely different proposition, a significant change from algorithms. Okay? And by the way, these patterns can be identified over everything, not just pictures. For example, financials, the texting, the text processing, the main company in the US is HR Block. I'm not sure if you guys happen to know. So every year in the US, every citizen completes a tax return and submits it. There's an entire, let's say, industry around that. At the premier company is this company, which what they do is they scan all the tax returns that they are submitted to them, which is a few million returns, and they identify patterns, and based on that, they can tell, first of all, how they can be optimized, but then identify errors and issues and so on, not knowing exactly how that works, but by the same way. Just like you take a picture and converting them into a matrix and then identifying patterns, it's the same way we can look at data. The advantage is that if we want to do it manually, we have to choose, let's say, 3 or 5 points, or 50 if we want, and then run correlation in the typical statistical way. Whereas with AI, we don't have to specify what, we just have to turn it to the computer, and the computer can actually identify the patterns and actually tell us what's relevant and what's not, establish correlations if A then B and so on, which can be used in any propensity to buy or propensity to convert, in messaging, in journeys, in any sequence of events to accelerate and so on. Okay? So anyway, I wanted to give you a little bit of, let's say, context. There's maybe one other thing that I want to mention. In this, let's say, revolution in data, there was a relevant event, which I'm not sure how many of you know of that lawsuit that happened at Target in the US with a pregnant lady. Okay, quite a few of you know. For everybody else, what happened, there are many of these incidents, but we know about this because it ended up in courts. So what happened is that a data scientist at this company, Target, managed to create actually an analysis that identified that a lady is pregnant by looking at the purchasing pattern. Okay? And what happened is that then they offered discounts to ladies who were pregnant. However, a few of them did not know that they're pregnant. Okay? And Then they went to the store, they got this, oh, congratulations, and we want to offer you this and that, and they happened to be with the husband there. So, oh, you didn't tell me you're pregnant. Well, I didn't know that I'm pregnant. Okay? And they went to court and said, well, I want to find out from my doctor that I'm pregnant, not from the store. And my husband should found from me, not from the store, where's in the coupon. Okay? It ended up in court as a privacy issue. And when people saw this, I don't care about the privacy issue. How the heck did they do that? Okay, and then every single company was trying to match that. Well, we want our people. If you have as good as that guy, do the same thing, and tell me who's going to buy what do people prefer, what's the next thing tomorrow, and so on. And this thing about what's happening tomorrow is important. Why? Probably all of you have gone on the internet and saw that, let's say you shop for sneakers or for a fridge or whatever. Then for 2 months, all you see as ads everywhere is those damn sneakers and that fridge, right? Who has not had that experience? Doesn't know what I'm talking about. Okay, so pretty much everybody. Okay, now, you might buy another pair of sneakers if you see something that's really cool and say, oh, I want that as well, but you're not going to get another fridge, right? Okay, but for 2 months, that's what you'll see. So the better way to go about that is actually not to show people what they shopped yesterday, but to analyze the data, okay, and be able to predict what will they want tomorrow, ideally before they know that they want that. Okay? And that actually is really leading them, or leadership and so on. And it's also, let's say, profitable business. Okay? In any case, that's the kind of things that we're dealing with in Silicon Valley. The technologies like HTO make a lot of this possible. But what do you see if you guys have any questions, anything that I can tell you in particular, rather than give you going over the things that we did and projects and so on, anything that you want to ask about what we're doing there, and whether in the industry or at Stanford or anywhere else?
Yeah, I have a question. You mentioned something interesting about that big companies are controlling communication. And you talked about data and prediction. So what sort of related developments has been done on that front?
So the main thing there is that there are quite a few large companies in Silicon Valley. This way it starts, and every one of them is seeing the trend and working to improve their communication to their customers first and foremost, and then their prospects, and then society in general, even to their own employees. Because some of these companies, Oracle, for example, is 160,000 people in the companies, 160,000 employees. Interesting enough, I'm not sure if you guys know, Denmark, for example, sent an ambassador to Silicon Valley. And now Silicon Valley is an ambassador, and they were talking about sending an ambassador to Google. Okay? So these places, they motivated, and they actually issued a press release saying that Google is as influential as half the countries in the world. Okay? So therefore, they send an ambassador there. Okay? Now, with that in mind, these companies are big, they are like a country. So in the end, what they want to do is to, rather than let communication happen at random, they want to, one, control it, but second, which, by the way, this is because when we hear about control, we might get concerned, but it has both good and bad. We are bombarded with a lot of communication. Everybody probably has tons of junk in their email, and no matter what you do, you put filters, you do this, you do that, you still have quite a bit. Plus, you get bombarded everywhere you go with a lot of information. We would like to somehow have the universe or whoever, or the companies, ensure that whatever they tell us, we want it, it is relevant to us, okay, and somehow filter it. And if somebody does that, just like in real life, if somebody comes to you and talks to you, I don't know, talks to, let's say, you about, I don't know, about lipstick, okay, you might not care. Or maybe to you about American football. Do you care about that? Yeah, no, okay. Now, if they, if they come and do that, and they do it again and again, and what will you do? Next time you see them, you go on the other side of the street, right? Or you'll avoid them, okay? That's what happens now with communication society. When somebody calls you to sell you that timeshare or something, oh my God, you don't know how to get off the phone, okay? And a lot of other things. So what you would like, however, you might be interested in lipstick, and you might be interested in football or something, Okay, so if somebody tells you exactly that, and you're wondering, well, what was the score today? And somebody comes by and says it was whatever, Rangers 1-2-1 or whatever. Okay, we say, well, how did you know? I like that. Who are you? I want to talk to you. Okay, that's something that we would appreciate. Well, that's what companies want to do. They want to give you the relevant data that you're interested in. Okay, and that actually is not a bad thing. We would want to have less information that we don't care about and more information that we do care about. Okay? Now, in order for companies to do that, they need to know a lot about you. And some of it is actually, let's say, fixed attributes. Okay? That's what we call them in marketing. So data like your, let's say, your gender, your title, your, whether you're technical or business or anything like that. Second, your behavior. Okay, what you've been doing in the past, and then infer from that and from society in general, any models, any patterns. If you do these kind of things, people like you in general, or with this kind of behavior, are also interested in this other thing. Okay? And then the assumption, it's not tested, but the assumption is that that might actually improve your life, or you might like that, or you might appreciate that. And that's what companies are trying to do. So that's the good part. The bad part is also, like everything else, atomic power, for example, can be used to light the room or for a war. Okay? This kind of things can be used for both good and bad. Okay? But the assumption here is that one, they can have a good impact in society. Second, companies obviously also do it to sell more and to be more effective and progress their agenda and so on. Okay? So going back to your question, what companies do is actually trying to make communication more efficient, more tailored, targeted, focused on what you might want to do, and then actually lead society in let's say, behavior. The society is changing, we all know that, in many different ways. And rather than leaving the change to be random, people want to direct it, and many times go to where they want it to go, whether it's bad or not, by the way, it's good or not, whether it's good or bad, I mean. Okay? Anyway, and there are concrete examples. I have actually tons of slides. If you want to see more slides, I'll show you that. But that's quite detailed. Anything else? Any other questions?
Related but not about the talk, what's your opinion on net neutrality that's now going on and how it will affect businesses in big data and information?
So that's both a technical and a political issue. And the political part it can be deep. Okay? The main question that I personally have is, since you asked for an opinion, is what arguments are really valid and which are not in this discussion. And the topic is complex, so I'm not sure I want to address it right now because we will have to discuss it in detail. It can be easily interpretable. The question is, what are we better off with? And people have made arguments on both sides of the issues that are very strong, and it's very difficult. I know, again, I don't want to make it even worse, but it's the same with, let's say, abortion. Okay? If you hear very strong arguments for one, very strong arguments for the other, and if you listen to just one of them, you might actually agree with them. And you listen to the other, and that sounds like a good argument. It's a difficult issue. It's not that clear-cut, like many other issues like this. It's not that easy to say, yeah, well, we should have this or we should have that. And the more I looked at it, the more I think it's complex. And I think it's also politicized. It's very little understood. People who don't really have no idea what they're talking about, they think, oh, let's fight the big corporations, or let's fight these particular corporations. And in the end, it's debatable. That's my opinion. Okay, but again, as you can see, I'm deliberately a little bit vague here because the issue is actually complex and it's very political. Okay. Anyway, and there are many things. Just to simplify it, for example, right now, or the internet actually started in the U.S. by the way, so that it got designed, developed, and so on in the U.S. I think it's overall it's a good thing. Some people might argue about that as well. But the question is, do you want to democratize it, and what will happen after that? Do we really have democracy? Is a good thing, of course, but does it really work everywhere? Do we really have the real democracies? Now, to get a little bit in more detail. And when you start talking about that and you analyze it and how it really works, not what people perceive and so on, as becomes problematic. Who do you vote for? Do you vote really for the guy who has the power, the lady who has the power? Do you indirectly end up there, whether in the US or in Europe for that matter, and so on? Who's the president of Germany? Do you happen to know? Who's the president of Germany? Or of Austria, let's say. Nobody knows, but that's the guy that they vote for. Okay? And it's an interesting thing. Okay? So in the end, democracies have their own way of working, and it's funny, and is anybody here against democracy? Nobody, but we don't really have it, okay? If you think of it. Okay, so the problem is a little bit more complex. That's what I'm trying to say. Okay, any other questions?
What was your path from Oracle and those companies you worked for to starting this business? What was the thing that made you want to start, and how did you develop your first clients?
So that's a good question, and these are two different questions. The path is not necessarily, I would say, standard or traditional, or maybe, I don't know. I'll tell you what it is. So I actually kind of made my money at Oracle. I got a lot of options when I joined. I had a key role. I was one of the two main people, the key contributors to Oracle 8, which actually allowed the company to kill their competition, which was Sybase and Informix at the time. It became the only company that had a viable enterprise strength database on the market for a number of years, and that made them a lot of money. It allowed them to grow, to buy their competition applications like Siebel and PeopleSoft and so on. And by 2005, I was very well off, so I started doing actually theater and education. I have a degree in education as well, educational systems, even though fundamentally I'm an engineer. And I helped the government in Namibia with their educational system, and went to Japan and Australia and national theaters in Europe with a show and so on. So as you can see, lots of different things. Went to Vegas for 6 months and played poker and so on. I'm a ranked player. So did everything else other than engineering. But at the same time, I helped a number of, as part of Stanford, I helped a number of startups and an advisory role. As you probably know, in Silicon Valley, everybody and their mother has 3 startups and 50 ideas and 2 patents and so on. And in that environment, I actually made a little, anyway, I was somewhat active. So that's the pattern. For about 5 years I did that. In 2012, again, working with a few people and seeing this trend in society of communication being industrialized, we started a company around a couple of projects. We were at Agilent, which is the former HP. I'm not sure if you know the story of HP. Started in a garage by Hewlett and Packard doing measurement instruments. But then later on, to make a long story short, HP is now known a lot for computers and for desktop and laptop computers and printers and so on. So the brand was left to associate with that, and then the instrumentation, together with actually the medical equipment, was spun off into Agilent, and then Agilent broke up into Agilent and Keysight as well, by the way. But anyway, around that and then Cisco, we had one customer in the beginning. Cisco was the main customer after finishing Agilent. That's how we started the company. We hired a few people. We hired them one by one. We didn't get VC. We grew organically. And then we got a couple of other customers one by one. When you're a small company, you don't need a lot of customers, depending on what business you're in. If you're in B2C, for example, yes, you need a lot. But if you're in B2B, you can grow to a couple of hundred people, even with 3, 5, 10 customers. And we acquired them one by one, 2, 3, 5 customers a year. And we have offices. So in Silicon Valley, we have a few people elsewhere, like in Ohio, North Carolina, and so on. Open an office in Toronto, in Madrid, in Vienna. Now we're considering here in Romania as well. By the way, we have 2 offices in Bucharest, in Brasov, and we might open an office here. And it's incremental. So we're debt free. We own the company 100%, so we didn't get any VC money. And that's our case, but it's the case of a lot of other companies. If you want to accelerate growth, or if you want to develop a product, which is a more significant investment, it helps to get VC money or angel or any seed money, anything that you practically sell part of the equity of the company and finance the growth that way. But we didn't. And our path is to possibly double in the next 12 to 18 months and maybe sustain that rate going forward. Maybe for the next 3 years or so. Should I take one more question? Yeah, somebody had there. Or anybody else? If not, we'll break. Yes, one more question or not? Yeah, go ahead.
Yeah, I just wanted to find out, so far in Scotland, what have you found out?
Say again?
What have you found out? You said you are
about Scotland?
looking for opportunities.
Yeah, so I'll make this very short and quick. And by the way, I'll be a little bit careful because I don't want to come across the wrong way that we didn't expect much, but we found much more than we expected. Okay, so I didn't know, for example, that the University of Edinburgh is it's actually the top university in the UK for computer science, third in Europe, 15 in the world. I didn't know that. Okay, I find the environment quite interesting, quite entrepreneurial, more so than in, of course, than in Italy or Spain, or I'm not sure if I should say, of course, because I don't have anything against those people, but even compared to Germany, which was very industrialized, developed, and so on. Even compared to London. I've been to London about 40 times, never been to Scotland before, but it's very positive. Okay, so surprisingly so. Again, I don't want to say that I had very low expectations, because it was not the case. UK overall is quite developed, but it has exceeded our expectations. Okay. Good, thank you very much. And by the way, if you want to, if you have any other questions or want to contact us, the name was there, so somewhere you can contact me and I'll answer to you.
I can share, I'll get details.
Okay, sure. Thank you very much.
And also in Scotland, we do projects like this. I've left this up for people to have a look at. We've probably, we've got half an hour left for a few more drinks, but we are, MBN again, are running a project with the Data Lab for any businesses who are interested. There's a lot of businesses in here who already are. We're working with 130 MSc students from 11 universities in Scotland, and we'll be looking for host companies to take these guys and girls on for their 10 to 12 week placement next summer. It's a huge success. So there was 52 students last year, and we found 48 of them a placement, and there was actually 78 open placements. We've already got about 30 or 40 placement forums in at the moment. So it's very, very high in demand, and it's from small startups right through to people at Morgan Stanley, HSBC, a wide range of clients, public sector, private sector, startups. So if anybody's interested, I've left the details up there, and I'll be sending this out to people in the meetup group soon anyway, so no doubt. So apologies, there has been quite a lot of kind of stuff going out through the meetup lately, but hopefully it is all relevant. It's people ask us to promote events and different things, so I don't, if anybody's feeling like they're getting spammed or anything, let me know, but I'm pretty sure it's all relevant. But again, thanks very much for the speakers, and it'd be great if you decided to come to Scotland. We would welcome you with open arms, and you've got the best talent and a really good, strong community here, and it's a good place to be. And it is St Andrew's Day. We've not got any music or bagpipes or tablet or anything, but we should have. But I was in London last night and I had the sleeper back, and I've not stopped for about 2 days. I might have organised it, but we do have some whiskey for the speakers. So thanks very much, and welcome to Scotland, and thanks very much, everybody. No, honestly. No, bro. Yeah. Cheers, that was brilliant. Thanks very much. Great.
Can I ask everyone just to stay for a second? So do one thing, because I forgot to do this photo. Is it all I do?
Yeah.
Yeah, well, so,
of course.
Together, so,
yeah. Okay.
It's not the thing from MIB, it won't erase your memory.
Yeah.
So
all right.
let's do that. Okay. 3, 2. Okay.
All right, cheers. Cheers, everybody. Brilliant.
Thank you.
Cheers.